Don't stress about it. Let's learn the derivatives. Basic differentiation formula. Let's all start with the first derivative. The derivative of constant is zero. Constant multiple some difference. Product rule, quotient rule, chain rule, yeah. Square root x is 1 over 2. Square root of x, the derivative of x is 1. You'll get better with your derivative, yeah, yeah. Better with your derivative, yeah, yeah. We can do this together. You're getting better with your derivative, yeah, yeah. Ba ba da ba ba ba. Da 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 da. Now let's go to trigonometric functions. The sine, cosine, sec, cotangent, cosecant. The derivatives of sine x is cos x. Cos x is equal to negative sine x. The derivative of tangent x is equal to secant squared x, yeah. Derivative of cotangent x is equal to negative cosecant squared x. You'll get better with your derivative, yeah, yeah. Better with your derivative, yeah, yeah. So we can do this together. You're getting better with your derivative, yeah, yeah. Da 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 da. Derivative of secant x is equal to secant x tangent x. Da 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 da. Da 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 da. Derivative secant x is negative cos secant x cotangent x. Better with your derivative, yeah, yeah. Better with your derivative, yeah, yeah. Don't you know? Now we can do this together. You're getting better with your derivative, yeah, yeah. Da 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 da. Derivative of secant x is equal to secant x tangent x. Da 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 da. Derivative of secant x is negative cos secant x cotangent x. Da 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 da. Oh, oh, yeah, yeah.
The numbers of dollars and the total cost of producing X units of a certain commodity is given by C of X is equal to 40 plus 3X plus 9 square root of 2X. First problem is find the marginal cost when 50 units are produced, while the second problem is find the number of units produced when the marginal cost is $4.5. Okay, so in order for us to solve the first problem, we are going to derive the given. So this is the given. C of x is equal to 40 plus 3x plus 9 square root of 2x. So we derive this and we get 3 plus 9 and you simplify 2x, square root of 2x. So that becomes 2x raised to the power of 1 half. Because in any other way, it can be stated as square root of 2x. So 3 plus 9, you bring down 1 half. And then copy 2 of x. And then 1 half minus 1 is equal to negative 1 half. And the derivative of 2x is 2. So 3, you're going to do this first. 1 half times 2 is 1, right? So you're just gonna copy 3 plus 9 there, and then this, you bring down this to the denominator because there is negative 1 half there, so it must be in the denominator and it must be square root of 2x. Okay, so let's go back to the first problem. The first problem is to find the marginal cost when 50 units are produced. So we already have the first derivative, and that is what we're going to use for our first problem to be solved. Okay, so this is the first derivative, remember? So we're just going to substitute x to 50. So, because 50 units are going to be produced for the marginal cost. So, first is substitute. So, 3 plus 9 over square root of 2 is 50. So, that becomes 3 plus 9 square root of 100. Then 3 plus 9, the square root of 100 is 10. So, 3 plus 9 over 10 is equal to $3.9 or 39 over $10. So, that is the answer for our first problem. And now that our first problem is solved, let's go back to the second problem. The second problem is to find the number of units produced when the marginal cost is $4.5. So for the second problem, we are going to substitute x with $4.5. So $4.5 is equal to 3 plus 9 square root of 2x. So we are going to multiply this with square root of 2x in order for this to be cancelled out. So when you're going to multiply this with square root of 2x, this becomes 4.5 square root of 2x is equal to 3 square root of 2x plus 9. Because if you're going to multiply it with square root of 2x, also the other side is also multiplied with the same number. So 4.5 square root of 2x is equal to 3 square root of 2x plus 9. So that's plus over there. So you're going to transpose 3 square root of 2x to the other side because we are going to combine like terms. So 4.5 square root of 2x minus 3 square root of 2x, that becomes 1.5 square root of 2x. And then the 9 here becomes the loner because it is the only one remaining on the other side. You're going to divide rather 1 by 1.5 in order for 1.5 to be cancelled out. So 1.5 square root of 2x divided by 1.5. So only square root of 2x remains. So, and the other side, 9 divided by 1.5. So this becomes square root of 2x is equal to 6. And then, in order for us to get the radical, we are going to multiply it by, we are going to raise it to 2. So you're also going to raise the other number to 2 there so that it's going to be even. So 2x is equal to 6 times 6, 36, because the radical is now removed. And then in order for us to get the x, we are going to divide it by 2. So 2x over 2, 36 over 2, that becomes x, is equal to 18 units. So that is the answer for our second problem. And now we have another set of problems which involves velocity and acceleration. So a weight is vibrating vertically according to the equation S is equal to 8 cosine pi thirds t. So the first problem is find the velocity of the motion for any time t. And the second problem is find the acceleration of the motion for any time t.
To solve this problem, first we need to isolate 8 from the remaining values. Then derive cosine. The derivative of cosine is negative sine x, then copy pi over 3t. Then second, you need to derive the pi over 3t, which is pi over 3. Then you multiply 8 to pi over 3. Then move the negative sign to the left side of the equation. Then multiply 8 pi over 3 to sine pi over 3t. That's why you get this answer. So this is the velocity of the second problem.
Okay, so we already have solved the first problem, which is to find the velocity. And now to find the acceleration, we are going to use the velocity that we have solved already. So this is the velocity that we have solved. Negative 8 pi sine pi thirds t over 3. So in order to find the acceleration, we're going to derive this. So as you can see, we can apply the product rule. So this is the u and this is the v. Ay, the quotient rule. Bugo. Balik. 2, 3, go. As you can see, we can apply the quotient rule. So this is the u and this is the v. So in order for us to apply the quotient rule, we are going to copy the v first. And then we are going to find the derivative of u. So 8 pi sine pi thirds t, the derivative of that is negative 8 pi cosine pi thirds t. If, in case you're asking why the negative is already put inside, it is because we are putting the negative inside the equation. So the 3 over here is already positive while this one is negative. And then the derivative of this is pi third minus, we are going to copy the v, the u. So negative 8 pi sine pi thirds t, and the derivative of v is 0 since this is a constant. Okay, so at the next step, we are going to simplify. So the remaining would be negative 8 pi cosine pi thirds t. Since this one is multiplied by 0, and since this one and this one, pi thirds times 3, it's going to be pi na lang. Right? Yeah. Okay, so the next step is we are going to simplify this. So as you can see, this side is multiplied by 0, so it becomes 0. So no need to copy because there's nothing to copy. And we are going to remember pi thirds times 3, it only becomes pi na lang. Right? So we are going to copy negative 8 pi cosine pi thirds t, but with another pi, so it becomes negative 8 pi squared cosine pi thirds t over the square of 3, which is 9. So that is our answer for acceleration. And now for the last problem. The motion of a spring is described by F of t is equal to e raised to the power of negative t cosine t. So for the solution, we are going to apply product rule. So this one is different from this one. So this is the u, while this is the v. So we are going to copy u, and then the derivative of v, or derivative of cosine t, is negative sine t. And the derivative of this one is 1. Plus, we are going to copy v, which is cosine t, times the derivative of u, which is e raised to the power of negative t, and the derivative of e raised to the power of negative t is negative 1. So we are going to simplify all those, and we are going to have negative e, since we are going to isolate negative sign, and we are going to place it in the first. So negative e raised to the power of negative t sine t minus e raised to the power of negative t cosine t. Oh, this is plus. That is plus. Oh, yes. Balik. Balik. And so we are going to simplify all those. So in order for us to simplify, we are just going to copy e raised to the power of negative t, and then the negative here in the sine t, we are going to isolate that, and we're going to place it in the first. So that becomes negative e raised to the power of negative t sine t. No need to copy 1 because it's understood. So minus e raised to the power of negative t cosine t. And then we are going to come up with negative e raised to the power of negative t sine t plus cosine t. Since if you're going to multiply this or distribute this to this equation, you're going to have this negative e raised to the power of negative t sine t minus e raised to the power of negative t cosine t. So this is the one simplified. So we are going to have this.